Alrighty guys, welcome to day 17 of Advent to Code. Just get right into it today. Go ahead, grab our input. This looks interesting. It's a very short input. Okay. Alright, you finally decode the L's message. Hi. Alright. The message says you continue searching for the slate keys. Ahead of what appears to be a large ocean trench. Could the keys have fallen into it? You better send the probe to investigate. The probe launcher on your submarine can fire the probe with any integer velocity in the X forward, Y upward or downward if negative directions. For example, initial would fire the probe straight up, while initial I would fire the probe at a slight downward angle. Arrow then will follow some trajectory by moving in steps. On each step, these changes occur in the following order. The probe's X position increases by its X velocity. The probe's Y position increases by its Y velocity. Due to drag, the probe's X velocity changes by 1 toward the value 0. That is, it decreases by 1 if it is greater than 0, increases by 1 if it's less than 0. Okay. Sorry, 0. Due to gravity, the probe's Y velocity decreases by 1. For the probe to successfully make it into the trench, the probe must be on some trajectory that causes it to be within the target area. After any step, the submarine computer has already calculated this target area. Your puzzle inputs. You need to find the initial XY velocity value such that after any step, the probe's X position is at least 20 and at most 30, and the probe's Y position is at least -10 and at most -5. Given this area, the only initial velocity that causes the probe to be within this target area is 7.2. And this diagram has the probe's initial position 0, 0. The coordinate increases to the right, and the Y. Okay. Wait. Okay. Okay. Because it goes through, does it? Okay. I see, I see. Interesting, that's like that. Okay. Super launcher might be well to do with style. How high can you make the probe go while still reaching the target area? Okay, find the initial velocity that causes the probe to reach its highest Y position while still eventually being within the target area after any step. What is the highest Y position it reaches? Okay, let's start by just doing this. Let's start by just coding out just call it the shoot probe. So I'm taking in X velocity and Y velocity. We're probably just gonna just brute force this is the way I can think to do it. I don't know any other way to do it besides brute forcing. So yeah, brute forcing it is. So int step equals 0 while, let's just do true for now. I don't have a condition at the moment. So while true, what happens is so we do need an int x equals 0, int y equals 0 as well. This might not be okay. The probe's X position is there, do the drag. So it's going to be X plus equals X velocity, Y plus equals Y velocity. Come on. And then do to drag, the probe's X velocity changes by 1 toward the value 0. So it's going to be X velocity minus equals math dot we want to move it towards 0. So it's going to be negative x velocity divided by that. That should move it towards 0, right? Because that'll give us always 1. But if it's positive, it's negative. If it's negative, it's still negative. That will do it, right? Because if it's positive x velocity, that means that's negative. This is always positive on the bottom, which means to subtract this 1. What am I doing? I mean, this works, but I should just be doing... Oh, because what happens if it's 0? The x velocity is 0, it doesn't work. Okay, okay, now we can just do x velocity is greater than 0. 1. Oh, why it's negative 1. Negative 1, sorry, other way. How can this be simplified? Oh. Interesting. Okay, we'll see if this works. If not, we might need to flip this. But we'll see. And then y velocity minus equals 1. Yeah. Okay, so this will calculate it, and then so this will give us our new position. And what we do now is check if it's in the target range. So if so we have the target range, right, which is that to that. Okay, so we do need draws a rectangle, doesn't it? It's an aught. Oh, an aught. I don't really want to use if it's an aught. Okay, so we'll do I'll just do target min x. I don't know why I'm doing this here. Let's just ignore it. Let's just do it all up in here. I don't know why I'm doing it here. If it doesn't matter. We can move it later. That's great. Just leave it. Leave it. Just leave it. It'll make it easier. Another line. It's fine. It's fine. So target min x, max x, and then min y, max y. So what this will do, if we're going to it, we can know if we're after it. Okay. So this is pretty easy. So we just do if the target min x is less than x and the target max x is, I guess it has to be equal because it inside counts. And then we do the exact same thing with the y's. So if all of this is true, we have landed inside of it. So this is inside target. Otherwise, okay, so this is going to be while so Boolean past target. So while we are not past the target is while this will run. What will happen here is we'll do an else if, and we know we're past the target when both the x and y are greater than, well actually in this case, because it's going to be going past this way, the target min y is less than y. No, it's greater than y. Because we want the min, because we'll be below it. We won't be out here. We'll be down here. I'm trying to use my camera here as like the grid, of the grid, you know, whatnot. We'll be down here, so we'll be positive x but negative y. So we'll be less than. Sorry, no, sorry. We will be less than the min y. Okay. What this will do is we'll switch to true, true. And then that'll end this loop here. Okay, and so if we're inside the target, let's have this return an integer. And we'll return, we need an int max y. And I'll make this integer min value. If y is greater than max y equals y, and this will return max y. Otherwise we'll return -1, I guess. Or we could just return the min value. It doesn't matter, just something that recognizes that we did not hit it. So that will do it. Don't care about the step. Okay. So if we were to call this, we should be able to hit it. So let's just, well, first let's parse this in. So, input get 0, replace that with nothing, and we can then call a split on the comma. So int min x equals parts, let's do another string. We'll do this, the x parts. So that's gonna be parts 0, replace. I guess we could do this all right here. Make it easier on ourselves. Oh, lost that, okay. Okay, and so now we can go back to this being int min x. This is not as efficient, but let's just call split on the dot dot, and then this is going to be 0, and again integer parse that, because that'll be our min, because it's always min to max, right? Yeah, cool. And that'll be the next 4 of them will all be that, just slightly different, because this is max x. So this is a 1, this is a 1, this is a 1, that's a 1, min y, max y. Okay, and then we can call, let's just do, to test this, shoot probe, let's grab one from here. Let's use this. So then we pass in 7, 2. Okay. So we pass in 7, 2, and then min x, max x, min y, max y. And what we should get is the max height. Oh. Because it doesn't like. There we go. I want the literal dot dot, not what it's trying to do. So I get 3, which is 1, 2. So this is right. Okay, so this works. Good. So now what we need to do is we need to do for int y equals 0. Actually, this is the only thing we care about, is if the target min y, if it goes below it. Okay, so let's do y equals 0 while y is less than 20, I guess. I don't know. I mean, we're brute forcing. I don't know what's. I don't know. Negative 20 to 200. I don't know. We'll just see what how fast we go, and kind of go from there. Okay, and then the x will be from 1 to 50. Pass in, oops, because that's wrong. Pass in x, y, and so we can just do is we want int max y equals integer min value, int height, and we just check here if height is greater than max y. Oh, max height, by the way. And at the very end, what we should be able to do is call a lap on max height, and in theory, they should brute force it, but how fast? Wow, decently fast. Sweet, okay, I was expecting that to not be nearly as fast. Okay. Maybe a fancy trick shot isn't the best idea. After all, you only have one probe, so you better not miss. To get the best idea of what your options are for launching the probe, you need to find every single initial velocity that causes the probe to eventually be within the target range after any step. Okay, so what we'll do here is we'll do so this I have no idea. Yeah, this one is a shot in the dark because I could be missing one. I ran debug mode, whatever. 119. Nope. Okay. Let's make this higher. Let's just push this to max. I have no idea. 996. I probably have to wait a bit. 30 more seconds. Okay. So this should be 112 is what we should get for this. Whoops. So we do get 112. Who is to say where our numbers, because of how big they are, who's to say where these are gonna fall? But 5 more seconds. Let's see if 996 is correct. Hey, it's right. We made the numbers big enough. I don't know. I'm sure there's some sort of math around like what is. I mean, I guess in theory. Hold on. In theory, the maximum x can only be max x because that's 1, 2 there. You can't go any higher than that. So it's technically max x. I don't know about the y. I guess it would start at min y and go to max y. No. This could be whatever. I have no idea on that. But will this give us 996 again? Nope. Oh, why did I put negative in y? Close. There we go, +1. So there we go. I mean, I don't know if there's a math way to get this, but I guessed it, I guess. Yeah, so, okay, there we go. So there, how did I do on that? 378 and 662, not too shabby. I'll take that gladly. Okay. As always, let me go ahead and clean this code up, if at all. There's not really much to do, so let me look through it, and if there's nothing else, but I'll come back to you guys here in a second, and I'll show you my answer, and I'll explain it. Okay, so yeah, there wasn't actually really anything to do. I moved this around because there's no reason to increase the velocities if we're returning or we're done, but either way, yeah, so let's go over my solution here. So the TLDR for today's problem is that we are in our sub, we need to fire a probe, and we need the probe to land in the marked target area. If I go to the problem, so using this, so our submarine's at S, here's the target area, we need to fire our probe and have it land in the target area. We can only control the velocity at which we shoot it out, so the velocity in the y direction and then the velocity in the x direction. Those are the two things we control. And for part one, we need to figure out what is the maximum height we can reach while still landing in the target area. For part two, we want to just know how many different initial velocities can we have that will all land in the target area. I'm doing these both at once because these are doing the same logic all at once, or finding both values at once. So that's why I'm kind of explaining these both at once. So at any rate, here's our input is just kind of this. We just parse it out. We just kind of remove this bit here. Also remove this y bit. So all we're left with is these two, basically the numbers with the dots. We then split on the dots, and we have our 4 numbers. That's pretty easy in terms of this parsing here. After that, we initialize our 2 variables. One is controlling or keep track of the max height reached by any velocity, and then the second one is keeping track of how many of our initial velocities hit a target. And for this, I just go and brute force it. I don't know if there's a more fancy math way to do it, but this works and it's pretty fast, so I'm happy enough. For the brute forcing, we put the y goes from the minimum y, so wherever the target is, because if you shoot it any lower than the bottom of the target, you're never going to hit it because it's always going to be going further down. So that's the minimum value is the minimum y value we can shoot down is minimum y. The maximum y that we can shoot, the maximum velocity I chose is 500. I don't know why. It's just kind of a number that worked. I don't know if there's some way we can determine this max y, but that's what I did there. And then also for the x direction, there's no reason to shoot at 0 because if you don't have any x direction, it'll never reach the target area because it won't move if we don't shoot in the x direction. And then our maximum x direction is going to be the max of the target area plus 1, because if you shoot it that fast, after one step you've already passed the target in the x direction, so there's no reason to go above that. So that's why these values are there. And then once we do that, we then shoot the probe. We pass in the x velocity and the x and y initial velocities along with where the target area is at. The logic here is then here's our keeping track of where the max y is reached in terms of height. Here's our x and y of the probe as it goes, and then we keep track of whether or not it's past the target because our while loop will go as long as we haven't passed the target. For every step of this logic, we just increment our x and y values by the velocity as the problem says. Here we keep track if the y value we're currently at is greater than the max y that's been reached, we set max y to be this y. And then we do some logic here to know if we have landed in the target area, which is simply just tracking if our x is greater than or less than the minimum x, so the bottom of the target area, this way, the start of the target area for kind of shooting into this way. If we're within the minimum x value and the maximum x value, that means we are somewhere in here. And then also if we are above the min y and below the min y, we're somewhere in here, which means we are now inside the target area. This is just how you check if a point is within a box or a rectangle. And if we just return our currently max reached y, and that's all we need to do. Otherwise, we then check if our y is less than the target's min y. So if our y has somehow reached somewhere down here, it can never now reach the target. That's how we know we're done, we've passed the target. That's the logic used for that. At which point we set this to true, which at this point the while loop will end. I could have returned from there, but I chose to just do that. And then with every step, unless we hit the target, we then change the x velocity to be. This is fancy. This is kind of what IntelliJ just made me do, but this is basically coming down to if the x velocity is positive, we subtract 1. If the x velocity is negative, we add 1. If it's 0, we don't do anything. And then we always decrement the y velocity by 1. And then after we get the max height from the probe, if the height is greater than the min value, because we return the minimum integer value if it goes past the target. So if the max height is greater than our current max height reached in total by any probe, we log that. Also, if the height that has been reached is not the minimum value, that means we hit the target, we increment our value here, and then we log them. And that's all it is. That sums up day 17. So not too bad overall. I'm glad that the brute force solution worked, because I was not going to be happy if I had to figure out some sort of math equation for this, but luckily this worked. So yeah, but anyways, that's all for day 17. Hope you guys enjoyed. I'll see you guys tomorrow for day 18. Peace out.